Hello again. This is an update video, but I decided to be a little more explanatory in this one, and I'm going to start at a higher level. My wife and I have a farm. Our kids work on the farm with us. I have a normal full-time job, and my wife has a normal full-time job. We have animals on the farm. We have chickens, we have ducks, we have pigs. We have a greenhouse. We're starting up an aquaponics system. We are already doing a lot of work every day. It is very tedious to manually walk around and check all the animals, check everything that's going on, make sure they have feed, water, make sure they're not too hot, such like this. So as we start building this farm up more, we decided that it would be a good idea for me to use what I'm good at my day job, which is firmware, software, electronics, stuff like that, to utilize that to build ourselves a system that will allow us to monitor the things that we care about for taking care of the animals and plants in the greenhouse, and then notify us when things go wrong. Temperature's too hot, there's not enough feed, water ran out. Those notifications would be amazing if they went to the cell phones in our pocket. So I started working on this, and I never did a video explaining that that's what I'm trying to do. That is what I'm working at as a goal. The end system will have a server that runs on a PC or a server, dumps information into a database. You can recall it and look at historical data for temperatures, feed levels, calculate a lot of stuff. We'll be able to mine that data to calculate how much it costs to feed animals, yada, yada, yada. Notifications will get recorded, notifications will get sent when the feed runs out, water runs out, something goes massively wrong. We can look at that data and help us automate the farm better and be more efficient, save money, and keep the animals healthy. That's what we're working on. Overall, that's the overall thing. My part and where I'm using my skills outside of building enclosures and stuff like that, manual labor, is to do the electronics and firmware and software part, because that's what I do for my day job, and that's what I enjoy. Computer science, period. So the last video I went in a lot of detail. This one, what I'm going to explain is the microcontroller sends messages to the Wi-Fi module. The Wi-Fi module sends messages across the network over here to a server, and in this case I'm using Netcat temporarily. When that happens, you'll see a message, and then the response goes back to the Wi-Fi controller, and then another message is sent from the microcontroller to the Wi-Fi module back to the server, and so on and so forth. This interaction happens roughly 20 times a second. You'll see in the logic analyzer trace that the microcontroller sends the message to the Wi-Fi module. That's this blue trace. The Wi-Fi module sends a response back to the microcontroller, which is the green trace, and then debug output, which will appear on this console here, shows on the purple line. The yellow line, the status LED, indicates that the real-time operating system that I'm working with, that my friend Bernie wrote and I assisted with, is reaching its idle task, meaning it has no processing to do. So every time the light flickers over here, and this yellow line goes up and down, it means that there's extra processing power in the embedded system to do more stuff. So I'm going to turn this on, and you'll see this whole thing start up, run, connect to the network, and start to send messages. And you'll see that happen. And as that happens, you see them come across the network here, and you see that the message, that the number of milliseconds after the embedded system booted increments continually, very quickly. As this is test firmware right now, it's not reading any sensors, it's just sending the simple message, I can get an end-to-end test. So I can take this as it is now and write the server and have that deposit data in the database, and then I can look at the data in the database. And then once I have all of that working, I can build the rest of the protocol out, add sensors, write a driver for the sensor, have it read the data, send it to the database, and then eventually write a web page or something, or a phone app or something like that that reads the data, and then add on to this whole thing. So I'm getting much closer to what I want, where I want to be, being able to connect on the network. So I'm going to stop this and stop this, and then what we'll do is we'll find a message somewhere. I don't know where we'll find it, but we'll find a message. So find any message. So probably this one, I guess. So what we're looking for is we want to see a message that says 69,440 milliseconds after boot. So it's been a while since I used this. But I think I can search for that, which is really cool. I like the way Saley Logic updated their UI. Can I search for that? Maybe I can't search for that. I don't know. Alright, well maybe not. So what we'll do is we'll just keep going back until we see something that looks like that. How close did we get? So let's see. It's 28. It's probably a while away. It's 28, 8:30. So where are we at? That one. Let's see if we can get it this way. This way probably be faster. Yeah, look at that. That's pretty cool. So 28, 8:30. 28, 8:30. 28. We're getting closer. There we are, 28, 8:30, right? So it was sent here. What we're doing is we're telling the Wi-Fi module, hey, I want to send you 35 bytes. And it says, okay. And then we send the message, which includes the 28, 8:30 milliseconds after boot as the message. We send that up there. Now, the Wi-Fi module is busy attempting to send, however, everything's running in an interrupt routine, so it received the 35 of the 36 bytes. So I'm probably sending too fast in my test code, which is fine, because it still kind of works. So it received 35 of the 36 bytes, which means then it read and it received everything most likely up into the /r. So when we look at it, that's probably what it received, and there it is. It received everything up into the /r. So that's cool. So it went off across the Wi-Fi from the Wi-Fi module. It told us that we received it, and then we see it over here. Not right now, because we stopped it well after the fact. But the point is, we have in the logic analyzer trace which monitors those UART lines that shows that the microcontroller sent it to the Wi-Fi module. The Wi-Fi module sent it across the network because we see it on Wireshark and we see the data. And the server, pretend server, has already recorded it, displayed it to us, and continued to run. So if this was depositing in the database, we could go to the database and see that information in the database, no problem. We would see that exact message. So that's where I'm at. This is entirely why I'm doing it, and that's actually where I'm at right now. I have it talking on the Wi-Fi. I have it sending messages across TCP/IP, and it works. There's some kinks. I know there is. There'll be more updates in the future. But this is where I am, and I'm kind of happy with this progress. So hopefully this explained more of what I'm doing instead of all these smaller cryptic updates that just show some neat, interesting, really intricate electronic or firmware kind of thing that doesn't make any sense as to why I'd be doing it, other than I'm probably some kind of weird geek. So have a good day and enjoy your weekend.